There are two types of eclipses. First up, a lunar eclipse is when the moon gets eclipsed. It is when the Earth's shadow is covering the moon. So you're going to have a situation with the Earth and the moon, and the sun is over here. I realize this is the worst demo that you have ever seen before. Just what I had handy. In case you're wondering, this is not quite to scale in any way, shape, or form. But anyway, so the Earth is in the middle during a lunar eclipse. What phase would the moon be in? Ooh, that's a full moon. It'd be a full moon out. So you can only have a lunar eclipse during a full moon. We'll find out later in the hour why we don't have one all the time. But it's going to be the Earth's shadow covering the moon, but it will be a full moon when it happens. One nice thing about lunar eclipses, they last a nice long time. So you find out through social media that there's one occurring, you're going to have time to go outside and check it out. We've had astronomy night where we start the astronomy night right at the beginning of the lunar eclipse and end it right at the end, and it works out very, very nicely. We'll have to find out if there's going to be one during this school year. I don't know yet. I haven't investigated that just yet. Okay, to be honest with you, lunar eclipses I don't think are all that spectacular. I mean, a lot of times they'll be happening and you won't even realize it. I've literally been sitting places outside with people, let's say at a restaurant, outside patio. I'll be like, what do you think of the lunar eclipse? And they're just like, what? When is there going to be a lunar eclipse? Oh, there's one happening right now. For real. Because you just don't notice it. Yeah, it's a full moon and it starts to get a little darker because of the eclipse. But guess what? In your mind, you don't think anything weird is happening. You just think there's a cloud maybe covering the moon at that moment. Even people probably looking straight at it probably don't realize what's happening as our shadow crosses the moon. Okay? But there are some really good things about it. Now, my favorite part, everybody's favorite part of a lunar eclipse is this. It can make the moon look reddish. And I think what's really important here is that you learn one of the basic facts of science. And this will answer some questions, a lot of questions people have. One of the most common questions I get is, Mr. Jeter, why was the moon so yellow last night? That kind of thing. Well, here's why. First of all, little physics reminder. White light consists of all the colors, right? But what is a color? Well, a color is a different wavelength of light. And red light has longer wavelengths that are separated by more space, longer wavelengths. And blue light, the blue end of the spectrum, has shorter wavelengths. Why does this matter? Well, when light passes through an atmosphere, like our atmosphere, the longer wavelength red is able to snake its way through better than the blue. The short wavelength blue and violet will get scattered before it ever gets to your eyes. So the bottom line is, our atmosphere acts like a big filter, making light appear more towards the yellow and the orange and the red. It's why when the moon is first rising, it's yellow sometimes, because when it's low, you're seeing it through a whole lot of atmosphere, right? Now, if you go to the movies and you see a big yellow moon rising in the east, by the time you come out of the movies, it's going to be white, because it's going to be above that atmosphere. Same thing happens when the sun sets in the west. All of a sudden, the sun appears very orangish, because our atmosphere is acting like a filter. Now, what does this have to do with eclipses? Well, what's happening is some of this sunlight here is actually grazing our atmosphere before it lands on the moon. Some of it's going to get scattered, some of it's going to refract. It's going to end up, a little bit of the light ends up on the moon, and the light that ends up on the moon has already passed through the filter of our atmosphere, making it more reddish. So the moon can appear red. Now, why is it red sometimes and not others? Why is the moon sometimes very yellow and sometimes it's not? That usually depends on basically how much stuff is in the atmosphere at that moment. Example. The next time there's a fire out in the Everglades, and there are a lot of particles in the air, make sure you catch the sunset that night. It will be spectacular. It will. The sun will be a very deep orange when it sets because you're looking through a particularly thick filter that night. There'll be a lot of particles. Okay? And sometimes we don't even realize why, because some volcano on the opposite side of the earth erupted, and yes, it actually affects our sunset here. It's really amazing because there are just more particles in the atmosphere. It's kind of neat. One other nice thing about lunar eclipses, even though they're not all that spectacular, the good thing is that if your weather is clear, you get to see it. That's nice. That's really nice. If you have a clear night and you know when it's happening, you're going to get to see it. Everybody on the nighttime side of the earth gets to see it. And it's one reason that we think in our minds that lunar eclipses happen a lot more frequently than solar eclipses. They don't. They happen with about the same frequency. It's just that you have a great chance of seeing this one, and you don't have a good chance of seeing the other type, which we'll get to in a minute. Let's look at some pictures. Now, we're going to look at some great pictures here today. iBooks. This is perfect for a gallery. I want you to grab a whole bunch of lunar eclipse pictures from a folder and pull them all in at once, and you just made a gallery. Same thing with solar eclipses. Real easy to do. All right, so we have a nice one. You can see just a little bit of this copper glow there on the moon next to Big Ben. Nice one over the mountains there. Now, photography team in other classes is, I'm telling them that this is the kind of picture where you take a picture maybe every 10 or 15 minutes, and you get this kind of shot, which is really nice. Isn't that cool? And you can see, again, very white here, and then right in the middle, right during the eclipse, clearly a different color. Now, this next one, they took the exposure much more often. So about every 2 or 3 minutes, look at that. That's one of my favorites. Okay. Pretty nice. And you can clearly see the color difference. This next one's very interesting. This next one was taken in Antarctica. Now, the path of the moon is going to look very different from there because the moon is going roughly, it's orbiting near our equator. Look at what it looks like from the bottom of the Earth, so to speak. That's what it looks like crossing the sky. I thought that was amazing. That one really made me think twice the first time I saw that. Pretty neat. That's a lunar eclipse. But much more awesome than a lunar eclipse, of course, is a solar eclipse. Now, for a solar eclipse, this time it's going to be the moon's shadow on the Earth. So the moon is in the middle this time. The moon is in the middle. What phase would that be in? That would be a new moon, right? You're not going to see the moon at night. That night, because it's out in the daytime. If it's all lined up correctly, it's going to block the sun, and you're going to have a solar eclipse. So, that's a new moon, and its shadow crossing the Earth. One of the great things about a solar eclipse, if you're ever fortunate enough to be somewhere where there is a total solar eclipse, you are going to know it's happening. You're going to know it. First of all, it is going to get so dark outside, you're going to see stars in the daytime. That must be amazing. Apparently, the temperature drops 10 to 15 degrees. So everybody knows that it's happening. Can you imagine ancient people, how much that must have freaked them out? There's a great scene. There's a movie called, have anybody seen Apocalypto? It's a really good movie. It's a big chase scene, and it's worth seeing. But there's a scene in that movie where there's a total solar eclipse, and the Mayans are watching it, and it makes you think about how ancient people must have just been totally stunned and fascinated and frightened by such an event. One of my favorite explanations for eclipses is that they thought a dragon was eating the moon or the sun, and it would pass through the dragon's body. I still kind of think that may be true. I'm not totally sure. I think we'll go with the book's explanation about the whole shadow thing. But anyway, keep the dragon in mind there. Here is one of the drawbacks of a solar eclipse. It's over fast. Maximum 7.5 minutes. That's it. If you're ever fortunate enough to see one, don't be that person that's like running out from the restroom 5 minutes late and you missed it. Okay? 7.5 minutes. It's amazing. Every year, guys, wherever there's a solar eclipse in the world, there will be a tour that goes to see it. And I always think, man, you know what? You could spend thousands of dollars going on that tour. Like I've seen cruises that just go out to the middle of the ocean just to see a solar eclipse, and all it would take is one cloud to ruin it. One cloud right in front of the sun for 7.5 minutes and you're done. So if you get the chance, definitely take it to try to see it. Now, another cool thing that happens during the eclipse, you see the stars and you also get to see the sun's atmosphere. What is that called? Do you remember? Yeah. You get to see the sun's corona. So especially for astronomers, but for everybody, that's pretty amazing. If you look in the poster up on the wall, you can see at the top of the poster there the sun's corona, that ghostly atmosphere surrounding the sun. We normally don't get to see that because the sun's so bright that we don't get to see its atmosphere. But during an eclipse, you do. Here's the biggest drawback. These solar eclipses are so amazing. And yet, if you think about it, I've been teaching this for a long time. I have never seen a total solar eclipse. I've seen a partial. But as much as I love astronomy, of course, you know it's on my bucket list to see one. And I'm going to show you on the next slide a really good time to see one. And it's not too far in the future. Anyway, here's the problem with the solar eclipse. The moon's shadow is small. So it's like taking a globe and taking a nice fine point Sharpie and drawing a line across the globe. If you're not right on that Sharpie line, you don't get to see it. Now, so you have to travel. By the way, if you think, you know what, I don't need to travel, I'm just going to go stand out in the courtyard of the school until one happens. Just so you know, if you want to try that, go right ahead. But on average, you would have to stand in a particular location for 300 years for a solar eclipse to happen at your particular spot. So I'm just suggesting you might want to travel. Let me show you where to travel to. Check out this map. I think this is really nice. I'll explain why some of them are red and some are blue in just a minute. Some interesting ones. I'm guessing the most seen solar eclipse in human history was in 2009. It went through both India and China. I'd say a few people got to see that. One of my students last hour was actually in Taiwan during that time and actually got to see it. Some other interesting ones. I remember the one in 2001. They took a cruise ship out of Miami through the Panama Canal just to go see that one. I thought the 2003 one was funny. Sky and Telescope have all these pictures of this beautiful, majestic celestial event, and the only ones watching it are like 5 penguins. It's really funny. So, guys, taking a look at the map, when is your best chance to see a total solar eclipse coming up? August 21st, 2017. Mark your calendars. That's mandatory. You have to go see it. I will change your grade retroactively. In college, I will contact your school and let them know, oh, they didn't show up to astronomy day to see this solar eclipse. Anyway, I'm definitely looking forward to seeing that somewhere. Now, we had a partial solar eclipse at this school the first year I started astronomy. The very first year I started astronomy class, and it looked just like this. It was about that much of the sun that was covered. Now, one of the sort of myths about eclipses is this. You always hear, on the news, everybody gets hyped up and they're all like, they kind of act like there's some magical thing occurring that's going to, hurt you looking at an eclipse. Here's my point. It is never good to stare at the sun. Right? It's like you don't go out this afternoon. It's fine, there's no eclipse. I'm just going to stare at the sun for the next hour. No, you don't do that, ever. Okay? But I'm just letting you know there's nothing happening here that makes it extra dangerous except for the fact it draws your attention. Everybody's going to be looking because there's something to look at. Anyway, that was a partial eclipse. The one that happened at our school, we made some little shoebox viewers. And I'm pretty sure all the other kids at the school, we're walking around the courtyard, all of my students with these shoeboxes, looking down at the ground. But because it was a partial eclipse, it wasn't any darker out. It didn't get any cooler out. So nobody knew what we were doing. They just thought we were a bunch of dorks walking around with shoeboxes. Oh, look at the eclipse. And so, yeah, it was kind of comical. Let's look at some nice pictures here. Oh, that one's courtesy of Mr. Eclipse. Thank you, Mr. Eclipse. So there is the sun's corona that I mentioned there. Very beautiful. Ah, this is an interesting phenomenon here. Right when the moon starts to move past, it's called the diamond ring. When the sunlight first peeks through it, you can see why there. The diamond ring. That'd be a nice one to throw into the iBooks there. Let me show you some more recent pictures I found that are just gorgeous. That one in Austria. Oh yeah, now that's a time lapse, obviously, where they're taking it every few minutes. I think for this part, we'll make it a little darker for the video here. They're taking it every few minutes. That's gorgeous, though. Let's look at this next one's gorgeous too. Look at this, the sun just setting. This was taken, I think, in Bolivia, I want to say, and watching the sunset over the Andes Mountains. Gorgeous. Oh, look at this next one. That would be fun as well. Going to some place, some ancient place like Easter Island or Stonehenge and seeing a total eclipse. That would be nice as well. Mysterious statues there on Easter Island. Again, guys, make sure you have a solar eclipse gallery. Would be wonderful. Okay, if you are in a total eclipse, you are in the darkest part of the shadow, and that's called the umbra. Good vocabulary term for you, the umbra. So I've never been in the umbra, but I was in a partial eclipse right here at the school, and that is a penumbra. Umbra and penumbra. Now I want you to think about something you probably never thought about in your life. Look at the top of the poster again. The top of the poster. That black circle is the moon. It's perfectly covering the sun in that picture. Think about that for a minute, guys. The sun and the moon are the same size in the sky. That is just an amazing coincidence. Think about that. That wouldn't be the same on any other planet in our solar system. Think how rare that is. And as a matter of fact, it won't even always be that way here. What is the moon doing? It's moving away from us incredibly slowly, a couple inches per year or something. But eventually, there will be no more total eclipses. So we just happen to live at a time in history when we get to see this beautiful event, and the moon just perfectly covers it. And why is that? The moon is so much larger, the sun is so much larger than the moon, but what? Yeah, it's so much farther away. Exactly, look at this. That's the amazing part. By coincidence, it's about think about that number, about 400 times wider than the moon. 400 moons to go across the sun. And yet it happens to be 400 times farther away. And the two things perfectly balance, and they're the same size. Most of the time they're the same size. But even now, guys, when the moon is at its apogee, when it's at its farthest point in its orbit, when it's a little bit smaller in the sky, it can't quite cover the sun. This is what we call an annular eclipse. You remember in the map it had some blue lines and some red lines? The red lines were total eclipses. The blue lines were annular eclipses. So an annular eclipse is when the moon doesn't quite get the job done. It's a little too small to completely cover the sun. Take a look at the bottom of the poster. I'll show you some slides here in a minute as well. The bottom of the poster, that's an annular eclipse where it's lined up perfectly, but it's a little too small to get the job done. So, altogether, how often do eclipses occur? Well, if you just looked at this model that I have, you would think that every time it was lined up like this, and every new moon, you would have a solar eclipse, and then 2 weeks later, you would have a lunar eclipse. And so you should have 2 eclipses per month is what it looks like. But of course that's not the case. Instead, we have one of either type about every 7 to 9 months. So why? Why doesn't it happen more frequently than that? Well, there's one little catch. The sun and the earth are sitting on a plane, right? We're going around in a flat orbit around the sun. The moon is going around in a flat orbit around us, but the 2 planes are tilted to each other by just 5 degrees. That's it. Just a 5-degree tilt. We would have eclipses all the time, but here's what we mean. Now this is such a silly little model that I have, but this is what we mean. Like in this case, the moon would be too low. So if the sunlight is coming from this direction, our shadow is going to miss the moon that month. So what has to happen is it has to be at one of the 2 points in its orbit. There are a couple points in its orbit. See right here it's too low, but if I swing it around, I can bring it up to the same level. That is called a node. That's going to happen twice in its orbit. It's going to be at a node. But even if it's at a node, that doesn't mean that it's lined up with the sun at that point. So both things have to happen. The moon has to be at the right plane, at the right node, and it has to be lined up perfectly with the sun. That's why this doesn't happen too often. That's why it's kind of a special event when it occurs. Okay, film crew, this is the kind of thing we need to explain. We're going to have some videos explaining this to help us out for the test. Here's the difference in size from perigee to apogee. Perigee, the closest point there, looks like it's 34 arc minutes at perigee and about 30 arc minutes at apogee. That's the difference we're talking. And that's when they talk about a supermoon and all that kind of thing. That's what they're referring to. Here is the difference then when the moon covers the sun and it doesn't quite cover it up. That's an annular eclipse. Check out this picture. Tell me what's happening. Tell me where this picture would have to be taken. Yeah, this would be a picture from the moon of the Earth eclipsing. It's a solar eclipse from the moon. And it's a fake. Yes, this picture has never been taken before. It will in the future. But remember, we were only on the moon a few times. Half a dozen times we landed on the moon. 12 people walked on the moon. That's it. And they were not there during an eclipse, so they did not take this picture, and that is definitely a fake. Last thing today, I'm going to make this very quick. iBooks, you do not need to make this a section. You're done with the book as far as the sections go. You still need to take the notes on this. I've already talked about from horizon to horizon to 180 degrees, and if you divide that up, 1/60th of a degree is an arc minute. Think about how small that is. That's a very small slice. A degree is already pretty small. How wide is your thumb? Do you remember? Half a degree. Thank you. Half a degree. Your thumb at arm's length is about half a degree. So dividing a degree up into 60 gets you an arc minute. Now just like in track and field, we use 1 dash for minutes. 1 dash for minutes and 2 dashes for seconds. So, if I want to give you the width, the angular size of the sun or the moon, I can say it's half a degree. Just like I can say, hey, the bell's going to ring in half an hour, or I can say the bell's going to ring in 30 minutes. It means the same thing. That's an arc minute, and of course arc minutes can be sliced up into 60 arc seconds. Now that is a small angle. Guys, if you stood out on the balcony and I drove over to the Walmart parking lot and held up a dime, the width of that dime, if you could see it from here, would be an arc second wide. Okay, if you have super sighted, you can see a mile away and see the width of that diamond, measure it, that would be about an arc second. That's an amazingly small angle, and astronomers use that all the time. Angles that small and smaller. We use fractions of an arc second to measure things called parallax shift and so forth. Here's a nice picture for the iBooks just showing 1 degree, what a small slice that is, and then you take that and slice it into 60, and that's an arc minute. The dark blue line is an arc minute, and then you take that and slice it into 60, and that's an arc second. Incredibly small angle. Any questions in today's lecture? Okay, guys, thank you for listening.